Okay, so if acids and bases are all sort of classified by their pH from 0 to 14, we need to understand what pH is. And so the answer to that is that it's just a formula. The little p is a mathematical function that just means negative log of something. And the something is whatever comes after it. So by having little p and an uppercase H, which is always how you're going to write pH from now on. Don't write it like this, because when I see this, I'm thinking phosphorus and hydrogen, and that's a really weird combo. It's missing something. Okay, there. I fixed it. Now it's a real compound. You don't mean to communicate that pH is a compound, so we're going to be careful about writing lowercase p, uppercase h, because lowercase p means the negative log, and the H part means concentration of H+. Now, when we write things in brackets like this, this means molarity. And if you recall from the solutions chapter, that means moles of solute per liter of solution. Okay? So whenever we're talking about pH, if we know the molarity of the hydrogen ion, I can calculate pH. All right, and so what's interesting about this pH scale is that very small changes in the pH correspond to a really big change in H+. All right, so let's try this out. We can get the calculator out, and let's say I put in first, let me change the pen color. For our first example, let's put in a concentration of H+ where it is very small. Whoops, that's supposed to say 5. 0.005 molar. And then we're going to compare that with a different sample, like let's say 0.5 molar, so like much more concentrated. Now the way that you use logarithms on your calculator is going to be different from how mine does. Each calculator is a little bit different. If you need help figuring it out, please just come to my office. It's much easier to do one-on-one. You need to make sure you're practicing with the calculator you're going to use on the final exam, because this is going to come up. We're going to be doing it in class too, so you want to bring it with you. All right, so if I put in negative log of 0.005, it equals 2.30. If we put in 0.5, oh, by the way, every single time I'm doing pH, I always have 2 decimal places in my answer. That is the right significant figures, no matter what the concentrations have. Now, if I put in 0.5, the pH goes to 0.30, so it's dramatically different. So what we notice is by removing 2 zeros here, you have decreased this number by 2. So there is a relationship between that. So bigger concentration, so as H+ goes up, pH goes down, and it goes down much faster in the pH. So small changes in concentration have a really big change in pH. That's because it's a logarithm function, and a logarithm function is a kind of exponential function. So when people say things like, my student loan debt is exponentially increasing, what they mean is that it's increasing much faster than it should. And so logarithms are an exponential function. So small changes in concentration have a big effect on pH. Okay? And as it turns out, even really small changes in pH can change how the body functions. So proteins run a lot of chemical reactions in your body. Stuff like, metabolizing food, helping you breathe, all of these like really critical things depend on protein function. And if your pH is out of whack at all, it can dramatically impact those proteins. Normally, human blood is pH 7.35 up to 7.45. Individual people vary a little bit, but generally it's within that narrow range. If you have a patient whose blood is significantly more acidic or more basic than that, they're sick. Something is wrong with them, and we've got to figure out what is wrong with them pretty quickly. One example of this is something called Keto Acidosis. And so I had a friend who, when we were young, he was about 12, was admitted to the hospital with ketoacidosis. And basically the way that they knew that that was what was happening is because, number one, his blood pH was very low. Number two, patients with ketoacidosis pee continuously. And number three, they lose a lot of weight pretty rapidly. Okay, and so ketoacidosis happens when the body is not able to metabolize things correctly, and it's a symptom of undiagnosed diabetes. It can cause rapid weight loss, 60 pounds in about a month for my friend. And he wasn't a heavy person to begin with. So having undiagnosed diabetes can change the blood pH dramatically because the body isn't removing sugar from the blood. And so this has a direct effect on people's ability to breathe, because if your blood pH is wrong, then the oxygen that's supposed to be in your blood doesn't want to stay there. Okay, so we got to fix those things as soon as possible. So that's one reason we care about pH. We've got to learn how to use it. Also, I kind of like to breathe myself, and it turns out that the ocean supplies most of our oxygen. Algae in the ocean produce almost all of the oxygen that we need to breathe in the world. It's not actually trees, although trees help, of course. It's actually algae in the ocean. So the pH of our ocean is very, very, very carefully controlled. It should be about 8.2 to 8.4. But we're seeing over about the last 130 years that manufacturing and carbon dioxide emission is causing that pH to go down over time. So understanding how pH works and what it means is an important skill for any citizen. All right, so we have a bunch of different ways to measure pH. Some of these we've done in lab already. This is the litmus paper I was talking about. If we have red paper and it turns to blue, that means that it's a base. And if we have blue paper that turns red when I put the liquid on it, that means it's an acid. Sometimes you can even find litmus paper that gives you even more detail. So this is very vague. It's just either it's a base or an acid. It doesn't even tell you if something is neither. So you can get a pH paper that turns really red when it's a pH of 1 and then gradually gets, greener until you get to this really dark blue color, maybe purple, I'm not sure. But that means that it's a high pH, like 13 or 14. So this gives you like a relative scale. You can get the same thing in liquid form. So the pH paper here in the top picture is paper, but this is the same kind of deal in liquid form. This is made out of indicators. So indicators are things that that react in a specific color whenever they're exposed to, either an acid or a base. And you can actually make your own indicator at home with purple cabbage. You can Google it. It's pretty cool if you do that. And you bring it into class and show us. Maybe there'll be some points in it for you. Now, none of these give us like actual numbers, though. The only way to get a numerical representation of pH is to use the pH meter. And this is the one we have in the lab, so you've seen that before. pH meters are the most precise way to measure pH. They have some shortcomings, but they're generally pretty accurate if you take care of them. Okay. So, the two equations in this chapter are the one that I already gave you about how to calculate pH if you know what H plus is. And then the opposite of that is how to calculate H plus if you know the pH. So this is, let me write this over for you. It's 10 raised to the negative pH. And the way that you enter that in your calculator is very particular to the calculator, but you do need to use an exponent button of some sort. If you need help, again, just come to my office and we can figure it out. Bring your calculator. Okay, so by definition, acids have a high H plus concentration. And since this is defined as the negative log, so it's negative, that means that high H plus makes pH go down. So the acids are the ones that are here from 0 to 6, or 0 to 7, really. Bases are exactly the opposite. Bases have very low H plus concentration, which means they have a high pH, so the bases are over here. And of course in the middle you have water. So this is a nice diagram that shows you a variety of different substances and their relative pH. This is just to help you if you happen to have a TI-30XA. This one has a very confusing way of doing logarithms and stuff, so I've written out the process here. If you have any other kind of calculator, you can Google it. There's probably videos all over the internet. You can look in your manual, or you can come see me for help. Okay, so here's how we can test our calculator's abilities, really our ability to use the calculator. Orange juice has an H plus concentration of 5.01 times 10 to the negative 4 molar. Okay, so I know that my two equations are this and the opposite. And so all I have to do, all I have to do is determine which one I need to use. So, if they've given me pH, I will use the second equation rather. I'll use this one. If they haven't given me pH and what I've got is H plus concentration, then I'm going to use this one, right? And that's a pretty good rule of thumb generally. So they gave us H plus in this one, so I'm trying to solve for pH. So I'm just going to plug in the concentration into the formula. So it's also important to be able to use exponent notation with your calculator. So if you need help with that, please come by sooner rather than later. I don't want you struggling with your calculator to get these answers. So my calculator tells me that the pH of a 5.01 times 10 negative 4 solution is 3.30. That's pretty low. But we kind of expected that because orange juice is a citrus fruit, and so it's similar to lemons, which means it has a lot of acid. Okay, in the next problem it says, what is the concentration of H plus? So I'm guessing we probably are going to want to use the other equation because that solves for H plus. Okay, so that means I need to figure out what the pH is. So it says if the battery S is 1.2, so we're going to just write 10 to the negative 1.2. And so I put that into my calculator, however the calculator requires you to do it. It sometimes can be tricky. And we get 0.063 molar. Remember that there's no unit in pH, but the brackets mean molar. So I'm going to write that. So if you didn't get these answers with your calculator, it's probably not you, it's probably the calculator. Come and see me and we'll figure out what's going on. All right, the final bit in this chapter is about titration, which is actually what we're going to be doing in lab on the 24th.